Sorry guys, the lights turned off in my classroom, but now I'm back. So if we're looking at a normal female, what this actually translates to is that this is going to be a homozygous dominant. So this is information that I'm just telling you because it's not inherent. So if we have a normal female, she's going to be homozygous dominant. Therefore, if we take a look again, okay, we're using the letter N. Capital N means normal. This X is going to have a capital N as well as this X. So now when we come to this new word carrier, that's actually a phrase for somebody who doesn't show the trait, but they carry the gene for that particular trait. So let's say, for example, in the albinism video, the two parents were carriers for the albinism gene. They weren't showing it, but it's in their genetic information. So these people are going to be heterozygous. Therefore, we have our X again because it's a female. Remember, hetero means different. So one of them is going to be a capital N. The other one is going to be a lowercase n. Now for our colorblind female, pretty straightforward. Again, two X's. We know that the little n is for colorblindness, so both of our X's are going to have a lowercase n. So I'm going to go up to question 3 for this to help you guys out. 2 is telling you to make a Punnett square for, coming back to my highlighter, a cross between colorblind male and female who is not colorblind but carries the gene for colorblindness. So first and foremost, let's get our genetic cross going. What are our parents? Parent number 1 is a colorblind male. Okay, so he is a male, therefore XY. He's colorblind, so coming back to the chart, that's going to be little n. Parent number 2 is a female, XX, not colorblind but carries the gene, therefore she is a carrier. So that's going to be our heterozygous situation. And same deal as always, you put one parent across the top. Notice that the N stays with the X, but the Y is by itself, and then you put one parent down the side. So when you're bringing your alleles together for this one, you know, capital letters before lowercase, and that applies to the N. But one of the important things to remember is that X always comes before a Y. Whenever we mention a male's sex chromosomes, we never say YX. We always say XY. So bring them together. This one's little n. So we have a possibility of having 2 girls here. This one's capital NY. This one's little n with the Y. Okay. So now let's come down to number 3. This is essentially how you would do your ratios, but this is only asking you for the phenotypes. So again, there's 1, 2, 3, 4 boxes, but for this one, our denominator is not going to be out of 4. It's actually going to be out of 2. And the reason why is because if you take a look at what these questions are asking you, they're including the sex of the individual. Is it male or is it female? So the reason why it's out of 2 is because no matter how many kids you have, you will always have a 50-50 chance of having a male or a female. So notice that half of this Punnett square, possibility of having a female, the other half of the Punnett square is a possibility of having a male. So that's why our denominator for every single one of these is going to be 2. So now we just fill in the numerator. How many out of 2 are going to be colorblind males? So our males are on the right-hand side. It looks like one of them because only one has a little n. How many males are not going to be colorblind? Just 1. How many females are going to be carriers? Looks like just 1, that top one right there. How many are going to be colorblind? 1. And number of females without the gene, that's going to be 0. That means that everyone in here could potentially have that gene. Okay, so that's how you do the sex-linked traits.